Amazon Go is a more recent example of Amazon using machine learning and AI for for a pretty clever use case. It's a store in Seattle, and it's open to the public. So if you visit Seattle in the future, please drop by. And you literally go in. You just use a QR code to go in, pick up some products, and leave. And you never queue, you never need to wait for a cashier to be available, because we have cameras on the ceiling that look at what people are picking and putting in their basket, and we can charge them based on that. So these are just a few examples of Amazon, the greater Amazon family of companies using machine learning to invent new applications and new businesses. But obviously, I work for AWS, so my goal, my role is to help every developer out there use those same services to build cool stuff. It shouldn't be only for Amazon and Netflix and NASA and all the bigger players out there. It should really be for smaller organizations and even individual developers, even if they're not machine learning experts. And as it turns out, we have a large number of customers who run machine learning on AWS today. So we go from the really big ones, and we're really happy to have them. And Hotels.com is part of that. You probably heard that on the keynote this morning. And again, the likes of Netflix, NASA, Intel, and all the big ones. But also some smaller companies and a lot of startups actually who just don't have the skills and the resources to build complex machine learning solutions from scratch. They can just rely on those services we're going to talk about, and very quickly make their product and their apps way smarter thanks to those. So this is the machine learning stack at AWS today. We're going to focus on that top layer, minus recognition, which is not a language service. So we're going to discuss the other ones. As you will see, these are just an API call away, super simple to use. But just keep in mind, if you need to work with your own data set, if you need to train your own models, if you need to tweak a whole lot more than the high-level services let you do, then you can work with Amazon SageMaker, and we had a couple of sessions on SageMaker today, and feel free to ask questions at the end if you need more information. And of course, at the lowest level, you could fire up EC2 instances, CPU or GPU instances, and deploy any of the popular deep learning libraries or machine learning libraries to build your own custom solution and just do everything yourself. That's perfectly okay. But for this session, we're going to focus on the high level. Okay? So the 5 services I'm going to discuss and demo today are Transcribe, which is a service that converts speech to text. Translate, I don't think I need to explain what this one does. Poly, which is the companion service to Transcribe. So Poly will generate speech from text. Okay, so it's text to speech. Comprehend is natural language processing. It will extract information from text, extract entities, etc., as we'll see. And Amazon Lex is a chatbot service that lets you define conversational interfaces, either text-based or voice-based. Okay, so those services are I think extremely useful to developers, because again, they are super easy to use, and I will show you some code later on. You will see you get the job done in literally one line of code most of the time. So even though all those services are based on extremely sophisticated machine learning and deep learning models, you don't need to know the first thing about those. You just call those APIs and get the job done. Okay, and that's all there is to it. And most of these services are real time too. You could use those services to enrich your analytics, right? If you have maybe a data lake, if you have already a central repository with data, maybe text or generally language-based information. You can very easily plug those services into your analytics to extract sentiment, do translation, etc., etc. Again, just do it. There's nothing complicated about doing this. And of course, if you need to pre-process some of your data to then use those services, right? Let's say you have tons of chat logs or documents, let's say, and you want to extract specific parts of that from that data set to then use maybe let's say a text-to-speech or natural language processing. Well, of course, you can rely on AWS's big data stack, and again, it's very easy to combine maybe EMR and Athena, why not, with those services. So it's not, people tend to oppose big data and machine learning, but these are really, you can really combine them. You can really combine those, and as you will see, it's just a few API calls. So what would you use those services for? Well, let me return you the question. What do you use language for, right? It's everywhere. So maybe you want to capture customer conversation in call centers. Maybe you want to transcribe them to text, and then maybe you want to do sentiment analysis on that. Or maybe you just want to look for specific information, extract specific information from a vast collection of data. Maybe you want to do captioning, automatic captioning on video. Maybe you want to do real-time translation, etc., etc. So, I mean, we humans use language, right? So it shouldn't be difficult to find use cases where those services can help your organization. And we'll see some customer examples as we go as well. So let's look at the first one. So the first one is Amazon Polly. And every time I'm in the UK, this makes my job easier because I don't have to explain why this service is called Polly. So I can save 30 seconds. Polly is text-to-speech. Okay, so we support 25 languages and 52 voices. And this is the simplest service. You just pass a text string. You select a voice, which would correspond to a given language, and just call an API, and in real time you get back a sound file with the actual sound snippet, which you can save to play later in your app, or which you can use for real-time conversation. And this is what the Echo devices use. It's the same service. Okay, so if you have an Echo device at home, you're listening to Polly all day long. So it's not just speech. It's not just text-to-speech, actually. Of course, you could provide just basic text, but Polly also supports a markup language called SSML that lets you specialize, customize the way the speech is actually generated. So it's a markup language like XML, right? So here's an example. Let's check if sound works.
The price of this book is 45 euros.
Okay, let's try that again.
The price of this book is 45 euros.
Okay, so if you want, and thank you for the sound, guys. If you want to customize intonation, speed, pitch, etc., you can do a lot of things like that using those SSML examples. So let's look at a few more, because I think this is really one of the fun ones. So here's the Polly console, and as you can see, here are all the languages that we support, okay? And for each language, so let's look at British English, right? You can pick from Emma, Amy, or Brian. And of course, for all the other voices, it's the same, okay? So some voices have more languages than others, but this is how you use it, okay? So let's stick with British English, and let's try some more SSML examples. And I will share those, they're available on GitHub as well. So here's another example where you can customize the way, for example, the way numbers and dates are spoken. So let's check this one out.
Your reservation for 2 rooms on the 4th floor of the hotel on March 21st, 2012, with early arrival at 12:35 p.m. has been confirmed. Please call line feed 888-555-1212 with any questions.
Okay, so here, for example, even though the text said, 3/21/2012, we could actually pronounce the date in a friendlier way. We could change the phone format as well, and it would say, if we wanted it to say 888-555-1212, we could do things like that. Okay, so SSML is really about changing, intonation, changing the pitch, etc., but also specializing certain words. There's a newer feature which I think is really, really great. It's the breathing feature. So let's look at that one. And you have to pay attention, because if you listen closely to the previous example, there was no breathing, right? So let's listen carefully to that one.
Wow, that was quite fast. I almost beat my personal best time on this track.
Okay, so it's a bit of a noisy room here, but you heard the breathing sound, right? So you can insert specific breathing spots, or you could do this and say, well, just insert them wherever, wherever it makes sense, and Polly will figure it out automatically. Okay, just use the auto breath thing.
Amazon Polly is a service that turns text into lifelike speech, allowing you to create applications that talk and build entirely new categories of speech-enabled products. Amazon Polly is a text-to-speech service that uses advanced deep learning technologies to synthesize speech that sounds like a human voice. With dozens of lifelike voices across a variety of languages, you can select the ideal voice and build speech-enabled applications that work in many different countries.
Okay, so it might be a little difficult to hear, but you can hear the pauses for breathing, which just makes the voice much more human-like. Okay, so like I said, it's not just simple text-to-speech. It's really, you have many ways to tweak that speech and make it sound very, very realistic. And I think this breathing effect is very cool. We have more examples when you can actually simulate, fear and really being completely out of breath and surprise, etc. So you can build very fancy stuff here. So this is Polly, right? And again, the simplest thing. So here I show you the console, but it's really a single API call, as we will see when we look at the code examples. So it's all fun, but we have customers using it, of course. We have a customer called Duolingo. I'm quite sure you're aware of them. It's a language learning app. And they understood that the quality of the voice that students listen to is a strong factor in how well they learn, right? And that makes sense. I mean, I had a number of really poor English teachers, and their accent was terrible, and that didn't help me learn. So I had to learn on my own listening to heavy metal records. So now I've got all kinds of interesting vocabulary. That's hard to use in an AWS session. But anyway, so they run an A/B test, a number of A/B tests with Polly versus other voices, measuring student progress, actually. And they figured out students learned best when they were listening to Polly voices, right? So now for all the languages that Polly supports, Duolingo uses Polly. So if you're using Duolingo, you might be listening to Polly every day, okay? So pretty cool use case. Okay, let's move on to the next service. So the next service is called Amazon Translate. Again, pretty much self-explanatory. It's real-time translation. Again, one single API call, and you get your text translated in real time. It detects the source language automatically, so you don't even have to specify what that source language is. And today we support 12 language pairs, so that's the left part here. So we can translate from English to Spanish, Portuguese, German, French, Arabic, and simplified Chinese. And we can translate from those 6 back to English. So for now, you cannot translate from Spanish to Portuguese. I'm sure it's coming, but not yet. And we're going to add more language pairs very soon. So Japanese, Russian, Italian, traditional Chinese, Turkish, and Czech. Okay, and you can expect more as we go. Okay. The use case for this, I think, is pretty universal. I guess every company needs to translate one thing or the other. It could be customer emails, it could be any kind of content that you have. But one of our early customers for this is hotels.com. And as you can imagine, they are running and operating websites in many different countries and many different languages, and automating literally millions, automating the translation of millions of hotel pages and user comments, etc. Would be great, right? Doing this manually is just impossible. So generally, you don't do it, and that doesn't help your business, right? You want your business to run in the native language. So they're using Translate to automate the translation of large parts of their websites and comments, sections, etc., etc. And then, maybe for the top level pages, you need someone a human to actually go and review them and fine tune everything. But as it turns out, this is still much, much cheaper than translating everything professionally using human translators. So just scaling your translation needs. So let's look at a couple of examples here. Okay, so let's move to Translate. And I've got a few examples here. All right, so I took the hard ones, what I think are the harder languages. So this is obviously Arabic. So let's see how we do here. Okay, so I'm using the AWS command line to do the translation, but this is really completely identical to calling an API in Java or Node.js or PHP or whatever you want to use. Okay. So there you go. I don't speak Arabic, so if we have Arabic speakers in the room, you can come later to me and say, "Oh, that was completely wrong," right? But at least the English, the generated English, looks kind of okay. So it makes sense to me if I read it. So I have to guess it's a good or at least an okay translation. Let's maybe look at the other one, the Chinese translation. And again, I apologize for not speaking Chinese, but this looks like pretty good translation to me. And I have to say, these are quite random examples I took from Arabic newspapers and Chinese newspapers. I didn't look for examples that were, pixel perfect or word perfect, I should say. But I don't speak a word of Chinese, so for me, looking at this translation and understanding that, okay, this is actually about Saudi crown prince, blah blah blah. Okay, I get the meaning, I understand the text, and if it is a really, really high value document, then okay, maybe a professional translator could go and fix a few words or fix punctuation or whatnot. But this would be massively faster than just translating everything. Okay, so there you go, Amazon Translate, and more languages coming as fast as we can deliver them, I hope. Pretty cool tool. So let's move on to Transcribe. So Poly was text-to-speech, and Transcribe is just the opposite. Okay, it's speech to text. So today it supports English and Spanish. More languages coming as well. It will add punctuation. It will add timestamps, so you know exactly when a specific word has been spoken. Okay, if you want to do captioning, that's quite important. It supports high-quality audio, but low-quality audio as well, such as telephony audio, which is specifically important if you want to transcribe customer calls in call centers. So 8 kilohertz audio is actually well understood by Transcribe. It also recognizes multiple speakers, so not the actual people, of course, but it will say, okay, this is speaker 1, and this is speaker 2, and now speaker 1 again, etc., etc. And you can also add your custom vocabulary. If you have domain-specific words that are not well understood by Transcribe, you can add your own. Okay? Let's take a look. So this one is not real time, okay? So I did prepare the example, but we're going to listen to that soundbite that I recorded, and we'll look at the translation. Okay.
Hello, my name is Julian, and I live in Paris, France. Right now I'm recording a sound file because I would like to test a new service called Amazon Transcribe. This file should be long enough to give me a good sample, and hopefully Transcribe will be able to understand my French accent, and if not, well, that should make for a pretty funny transcription. This should be long enough by now, so let's stop the recording, upload that file, and get some results.
Okay, so just something I recorded on my laptop. I didn't pay a lot of attention to my accent. I spoke maybe a little slower than usual. Okay, so you could blame me on cheating with that. So what you would do, literally, is you would call an API. You would put that file in S3, call an API, and transcribe it. And if you wanted to start this with the AWS command line, this is what we would do, right? Start transcription job, pass the location of the file in S3, and within a minute maybe it's going to be available. Okay, so this is what you get back. Let's see how that looks. Okay. So this is the text. This is the raw text that I get. Okay, the raw transcription. So and I hope you can read that. Okay. The document that you get is actually longer. It is a JSON document with the exact timestamps, etc., etc. Okay. So there's not a lot of interest of reading JSON, right? JSON is for machines, not for humans. So this is the actual text that is understood. So I would say it's pretty good. So I did pronounce my first name Julian, so that's what it understood. And funny enough, the service doesn't know its own name, right? So that's probably the only mistake here. It says transcribed, which is the proper English word, I guess. So see, people are very afraid of AI, but not so much, right? Humanity can live for a little while longer, I guess. Okay, but just joking here, but the rest is pretty fine, and I can promise you I did not change anything here. Okay, so it is a high quality file. There's no background noise. I am speaking a little slower than usual. So yeah, I guess you could expect if I was my normal self speaking faster with music in the background, maybe we would have a few mistakes. But that's fine. We can, it's more than enough to understand the conversation. It's more than enough to run analytics, right? If you wanted to run analytics and extract information from this, we don't need every single word to be perfect to understand the intent. And if we really need somebody to go over this and fix mistakes, it doesn't take long, right? Much faster than listening to hours and hours and hours, possibly thousands of hours of customers complaining on the phone, right? This would be just faster, okay? So this is Transcribe, okay? Again, very intuitive service, I think. So again, I'm just having fun with those, but we have real customers doing real work. This is a company called ringDNA, and they build an enterprise platform for a sales team, right, to communicate, exchange data, and be more efficient. And one of the features in this platform is automatic transcription of all the VoIP calls that go through the platform. So it could be a customer call, and I think that's useful, right? Because you don't have to focus on taking any notes. You just focus on answering the customer's question and making sure they're happy, and you're going to have the full conversation later on, right? If you have a meeting with the team, an internal meeting, then again, no one needs to take any notes. By the time the meeting is over, you will have the transcription ready. Okay, so no more sacrificing to take notes during meetings. I guess that's the progress for all of us. The next service I want to talk about is called Comprehend. So comprehend is a bit different compared to the other ones. Comprehend is really about understanding what the text says, okay, what the meaning of that text is, what are the important bits. So you can use it in two different ways. The first way is just to provide a single document, and that could be an email or a tweet or anything really. And using, again, very simple APIs, you could extract entities, people, organizations, locations, significant things. You could extract key phrases, so the important bits, okay? You could detect a language. We can accurately detect 100 languages. So that's a hard problem to solve, especially if you have short pieces of text. It's not really easy sometimes to figure that out. And not every human, I guess, could detect accurately 100 languages in an instant, and comprehend can do that. And of course, it will do sentiment analysis, positive, negative, neutral. Okay. So, well, that's all there is to it, but let's take a quick look here. So again, just looking at the console, you could grab any piece of text. Yeah, that's large enough, I guess. And I like this view better. All right. You could grab any piece of text and just call the couple of APIs, to detect entities and extract sentiment, etc. And you get what you get from the API, obviously, is a JSON document, again, with all this information, okay? But it's easier to visualize like this. So the blue entities are organizations, as you can see, Amazon.com, Starbucks, etc. Orange entities are locations, okay? That reddish thing is a date, and the pink stuff would be people, okay? And we can also detect quantities and a couple of more things. Okay, so very easily you can extract that information from the document. You can get the key phrases. Okay, so here it is a pretty short text, but you could say, well, the important bits are these, right? And the rest is just filler, right? We can ignore those words if we want to. Language, obviously, here is English, but it would detect again 100 languages. And sentiment is neutral. It's very descriptive, so not a lot of emotion in this sentence, but it would give you more positive or more negative sentiment if you add stronger words in there. Okay, again, completely real time, just API calls and get those results. Okay. So if you want to do a sentiment analysis on customer reviews or tweets or things like this, that's all there is to it. There is another way to use comprehend. It's called topic modeling. So topic modeling is a different thing. Topic modeling is useful when you have a large collection of documents, and it could be millions, right? Really a large collection of documents. And the Washington Post is one of our customers for this service. And you want to figure out what these documents are about. Okay? So one way would be, let's index those millions of documents into some kind of indexing engine, and then we can do full text search and things like that. But, well, that never really works very well, right? And it's costly. It's going to require a lot of infrastructure to host and run. So there is a better way, and it's called topic modeling. So what comprehend will do here, what it asks you to do, basically, is to provide the number of topics that you want, okay? So you have your collection of documents in S3, and you just tell comprehend, okay, build me 10 topics, okay? So comprehend is going to analyze that data set, and it's going to build 10 topics. So the output that you get is, for each topic, a list of words that are really meaningful, and a relative weight, okay? And then, so you get that list back, the list of topics with the words, and then you get, for each document in the collection, you get a score on each of the topics, okay? And compared to the size of the data set, this is very little information, right? It fits in an Excel sheet, literally. It's very small. And so this is actually very nice, because using very little information, then you could actually query your documents. So if you had a stock market if you had a lot of stock market documents in this data set, you would have some kind of topic, and let's call it the stock market topic, with words like earnings and revenue and quarter and CFO or profit warning, maybe, hopefully not, etc., etc. And if you had a lot of US politics in those documents, then you would have a topic, and let's call it the Washington topic, and maybe it would say White House, Congress, Donald Trump, Twitter, things like that. And other words we don't want to know about. And using that, looking at the scores, then you could say, well, give me the 10 documents that score the highest on stock market, and score at least 50% on the US politics topic, right? And this is you get an instant answer. Because again, the list of topics and the scores is something that's so small that you could put it in a cache or in a very simple database. And even if you had a petabyte of documents, you would get an instant answer, right? And it would be an accurate one because it's based on machine learning. Okay, so this is topic modeling. So Clearview Social is using this, and they built a platform for enterprise employees to share content on social networks. Okay, so of course the goal here is to share content that is efficient, right? That gets retweeted and liked, etc., and that promotes and the company and creates visibility for the company. So in order to make sure that these messages are tagged with the best possible keywords, these messages are automatically analyzed by Comprehend to extract entities and so on, and tagged with those messages. And the interesting thing here is, since these keywords are guaranteed to be efficient, right, meaningful for the message, you can actually compare how much it would have cost to buy those keywords on, let's say, Google AdWords, right? So you can actually assign an ROI to those messages. Say, well, thanks to those messages, right, the equivalent spend on Google AdWords would have been this, right? So you can actually put ROI on those messages, which makes sense. So of course you can combine all those services, and I'll show you more demos in a minute. Here's an example where you could have audio input. It could be, again, customer conversations. Why not? And they could be stored in Amazon S3. You could trigger a Lambda function whenever a new file is dropped in S3. That's super easy to do. It would automatically transcribe that customer call to text. You could translate it, right? If you have international call centers, you could say, okay, maybe we want to put back everything to English because we want to centralize our analytics and just work only from English content. And then you could run that through Comprehend to do sentiment analysis, maybe entity extraction. Entity extraction will figure out product names. So you could do things like, okay, what are the top 5 product categories that create the most frustration with my customers, right? It sounds like a very simple question, but if you have 10,000 calls per day, doing this manually and in real time is very, very complicated. So by integrating those services, you could solve those problems just maybe in a couple of days, maybe less even. It's really easy. And then you could send this output to one of the analytics services like Athena or Redshift or RDS or any of them really, and build visualization and dashboards and reporting with QuickSight. And by the way, this is fully serverless as well, right? So it doesn't matter if you have 1 call a day or 10 million calls a day, it's going to work the same, right? No scaling required. Everything will scale automatically. So pretty cool, I think. But I'm biased, I know. The last service I want to talk about before showing you more demos is Amazon Lex. And Amazon Lex is a chatbot service. So like I said before, it lets you build conversational chatbots in text or voice form. Defining a chatbot will really mean defining the conversation, right? So we'll see an example on the next slide. And then writing the code that needs to be executed once the conversation is over, once you have extracted the required information from your user. Okay, so it runs on fully managed infrastructure. So again, you never have to worry about high availability or scaling. Just invoke the endpoint for the chatbot, and that's all there is to do. So here's a very basic example where we would like to book a hotel. Okay, so to fulfill the booking, we need 3 pieces of information. Obviously, we need the city. We need the check-in date and the checkout date. And yes, we need a few more things, but for the sake of simplicity, let's say we just need those, okay? So the user could say something like, book a hotel in NYC, okay? So the chatbot will first split these words, this sentence into words, and then it's going to extract meaning, okay? Because words like in, they're not really useful. We can discard them. NYC, we have, that's not really a city name, right? It's a shortcut. So we have to map this to New York City, and that's again the natural language understanding part. Okay, and so that will tell us that this city information, that we call this a slot, right, is really New York City. We could have we could do things like if the user says book a hotel, right? Book a hotel for tonight. We could say, okay, probably the user means in this place, right? The place is currently at. So if we have geolog information, we could say, okay, so then the city would be London, right? And tonight means whatever day we are today, May 10, I guess. See, and so we could really automatically fill those slots. And if we need more information, we could say, okay, how many nights do you want to stay there? The user would say, well, I want to leave on, I want to check out on May 15. Okay, so then we would know that's 5 nights, et cetera, et cetera. So the conversation is really, the purpose of the conversation is really to fill those slots. And once we have all those slots, then we can fulfill that conversation, and we're going to invoke a piece of code in a Lambda function. Okay, Lambda is one of our compute services, and this will actually call let's say the booking backend and actually book the room. Okay, so as you can see, a chatbot is really a conversation, and it's really you really define that conversation in text, and a piece of code to actually fulfill the intent. So we have plenty of customers building this. This is a popular application. Here's one of them. It's a U.S. insurance company called Liberty Mutual, and they built a Lex bot to provide car insurance quotes. Okay, so instead of going to a complicated websites and filling 10 pages of forms, you just open that bot, and I guess you could say something like. I'm interested in a 1969 Ford Mustang fastback, just a random example, and maybe you want to ask a few more questions to the user, and really quick, you can provide a car insurance quote, and you could do this in a mobile app, you could do this anywhere really. So just a simple and very user-friendly way of fulfilling a service to your customers instead of having to look for your driving license number and all the crazy amount of information that they usually request from us. Okay, so let's look at a few more examples. We have time for that. Okay. Okay, so we looked at transcribe. We looked at translate. Let's look at this one here. So this is an example of integrating all those things. So here's my $1 billion startup ID, right? And I'm raising money, so you might want to get in early, okay? Come talk to me after the session. Give you a good deal. So my $1 billion startup wants to automatically read text and images, right? Because I think that's a really smart idea. I want to detect the language. I want to translate this text into multiple languages and speak those translations, okay? So I want to do this. This is a Super Bowl ad, by the way, in case you wondered. So that sounds like a very complicated problem because I need to do image recognition, I need to do text detection in an image, I need to do language detection, I need to do text-to-speech in multiple languages, I need to do translation in multiple languages. A few years ago, this was really science fiction, right? You could not do it unless you were, I guess, a very large R&D organization and you had the best and the brightest researchers available. So what about today? Well, today, I guess, if you have a junior Python developer that can write 20 lines of code, you can do it. So I'm actually using recognition here to extract the text from the image. Okay, it's one of the features in recognition. I'm using comprehend to detect the language. I'm speaking it using the Brian voice, which is UK English, because yes, I know it's English, it's always the same picture. And then I'm translating it to Spanish, Portuguese, French, and German using Translate, and using Poly to speak those different translations. And yes, they have funny names, and of course the Portuguese voice had to be called Cristiano, right? So we have a bit of a football fan in that team for sure. So let's give it a try. Let's look at the picture again, right? All right. We've been waiting. All right. So let's not wait and run this.
We've been waiting.
Hemos estado esperando.
Estávamos esperando.
Nous attendions.
Wir haben gewartet.
Okay, so that's all it takes. 20 lines of Python, one API call to do each single thing, completely real time. And the question I usually get is, oh, how much does this cost? And I couldn't even tell you, right? Because it's all pay as you go, and we usually charge per 1,000 API calls. So I should actually compute that number for the maybe 10 API calls that we did here, but it's going to be fractions of pennies for sure. So nothing more, right? And again, if I need to scale this to hundreds of thousands of images, millions of images, it's going to scale because all of that stuff is fully managed, and we just call those APIs, and we never worry about a single server. Okay, so here's an example of combining those services. You can write this code in 2 hours and solve a problem that used to be unsolvable, I guess, a couple of years ago. So to sum things up, well, this is the family picture, I guess. So those high-level services. And like I said before, if you need to do more custom work, then please take a look at SageMaker, and again, happy to help with that as well. If you want to get started, well, I would recommend looking at the free tier, because you saw that free tier logo on every slide, and it means you can work, you can try all those services for free in the free tier, which lets you experiment for 12 months up to a certain usage level. So absolutely all those services are part of the free tier, so you can try them for free. I would recommend taking a look at this page, which is like the umbrella, the top level page for machine learning services on AWS. You will find all the services I discussed, plus SageMaker and customer references and everything else. The machine learning blog has a lot of examples. There was a blog post recently on how to automatically translate a Twitch chat using Translate, and we have many more on how to quickly and very easily combine those services to build very sophisticated apps. Okay, and last but not least, you will find the code examples that I showed you on my in this specific place on my GitHub repository, and you might be interested in my blog as well on Medium, where I tend to write quite a lot about machine learning and SageMaker and some of those services as well, right? So some content you might like. Well, I'm done, so thank you very much. I hope you had a good summit and a busy one, and that's probably the last session, right? And if you want to reach out later, the easiest way is just to ping me on Twitter. That's the easiest and the fastest way to get in touch. So if you have questions, or if you build something cool, and just ping me, I'm more than happy to to retweet and share it on my networks. Okay, thank you very much.